Good afternoon. Today I will discuss the inverse Laplace transform of a given function. To start with, here are the topics that we will be discussing for today. First, we will be solving Laplace transform using the tabular method. Next, we will solve the inverse Laplace transform using the divide and conquer method. And for the last method, we are going to use the rationalization method or the partial fraction expansion method. Okay, now before we start solving problems, we need to go back to our previous lesson, which is the Laplace transform of a given function. Now, for example, on this column, you can see your function of t, and on the other column, that is the Laplace transform of your function of t. So take note that the Laplace transform of this Dirac delta function is equals to 1. For the unit step function is equals to 1 over s. For the exponential function, that is 1 all over s minus 1. For t raised to n, that is n factorial all over s raised to n plus 1. For sinusoidal function, let's say sine bt is equals to b all over s squared plus b squared. For cosine bt, that is s all over s squared plus b squared. Now for the hyperbolic functions, like sine hyperbolic bt, that is b all over s squared minus b squared. And for the hyperbolic cosine function of bt, that is s all over s squared minus b squared. Okay, now let's proceed to our next table. If you can still recall, this is the table of your properties. Now if a function of t is multiplied by the exponential function, the result will be your first shifting theorem. That is the f of s when s is equal to s minus a. Now for the next property, we have the function of t multiplied by t. That is actually the derivative of your Laplace transform. If your function of t is divided by t, the Laplace transform of that is the integral of your Laplace transform. Now for the last uh, transformation pair, I have here the function of t minus a multiplied by u sub t minus a, that is simply e raised to minus as multiplied by the Laplace transform of f of s. Oh, this is actually your second shifting theorem. Okay, now what if we are going to solve this problem? Example number one, we have the inverse Laplace transform of 4 all over s squared minus 9. Now, if you can still recall, no, the denominator is s squared minus 9, and your numerator is a constant value. That is in the form of what? Right? That is in the form of hyperbolic sine function. If you can still recall, the hyperbolic sine function above, okay, is equals to b all over s squared minus b squared. Now, if we are going to take out 4 from the inverse Laplace transform sign, that would become 4 times the inverse Laplace of 1 all over s squared minus 9. Now, what is lacking in the numerator here? Take note of your transformation pair. So in this transformation pair, 3 is lacking in your numerator. Now, if I'm going to multiply 3 in your numerator, I will balance that by dividing 3 now outside your inverse Laplace transform sign. So this is actually a 1. 3 over 3 is just 1. Now, since the inverse Laplace transform of 3 all over s squared minus 9 is equals to sine hyperbolic of 3t, therefore, your final answer would be 4 over 3. That's 4/3 of sine hyperbolic 3t. So in this method, all you have to do is to familiarize the transformation pair. Okay, let's proceed with our next example. Supposing I have here the inverse Laplace transform of 8 all over s minus 2 squared plus 4. Take note, s minus 2 quantity squared here plus 4 resembles the function of what? Right, sine function. So the Laplace transform of sine is, if you can still recall, the Laplace transform for sine, what is that? bt is equal to b all over s squared plus b squared, correct? So it resembles the sine function. Now, if we are going to take out uh, 4 from 8, that will become 2 all over s minus 2 quantity squared plus 4. So take note, b here, b squared here, is equal to 4, and the square root of that will be equal to 2. That will be your numerator. So this is now in the form of the sine function. Now, take note of this. This is your shifting in the S domain. So if you have shifting in the S domain, meaning to say, if you are going to take that out, the shifting value, which is equal to 2, if you take that out, that is equivalent to exponential function. That is the exponential function of 2t. Take note, if I'm going to insert the exponential function, it will become s minus 2. All right. Now, what is left here in your inverse transform is 2 all over s squared plus 4, which is equals to sine of 2t. So therefore, your final answer would be 4 times e raised to 2t multiplied by sine 2t. So take note of the shifting in your s domain. That is equivalent to, now if you're going to take that shifting value out of the inverse Laplace transform sign, it is equivalent to an exponential function of t. Alright, so let's try another problem here. Supposing I have here the inverse Laplace transform of 1 all over s plus 2 cube. Now, if you will notice, s plus s here is shifted by 2 units. Now, if we are going to take s plus, if we are going to take out 2, that will become, okay, by the way, before that, this is in the form of what? Right, this is actually in the form of t raised to n, which is equals to n factorial all over s plus s raised to n plus 1. So in this case, if the exponent here is 3, what is the value of n here? Right, n is equals to 2. So when n is equals to 2, so it will become n factorial, 2 factorial, right? Now, since 2 factorial is lacking here, so in your numerator, we need to put that, so that our transformation pair will be complete. So we need to put the 2 factorial here, and of course to balance that, I will put another 2 factorial, but that is in the denominator of 1. So this will now be your function. Now, after that, if we are going to take out the shift, the amount of shift which is equals to 2, that will be equivalent to e raised to minus 2t. Take note, if we are going to take out 2 from s, this will become s minus 2t, leaving you s, no, leaving you s raised to 3. Take note, if we are going to take out 2, eliminate 2 here, and then take that out, it becomes the exponential function. So leaving you 2 all over s cubed. And we know that 2 over s cubed is just the Laplace transform of t squared. So therefore, your final answer would be 1/2 of e raised to minus 2t multiplied by t squared. Alright, let's have another one. Supposing I have here the inverse Laplace transform of 25 all over s squared plus 10s plus 25. Now, if we are going to manipulate the denominator, this will become, okay, by the way, if we are going to take out 25, so that the numerator will become 1, and the denominator is s plus 5 quantity squared, is actually the factor form of s squared plus 10s plus 25. Now, take a look at this one. This is in the form of the Laplace transform of t raised to n, right? Now, what is lacking in your numerator? Since the exponent here is 2, what is lacking? Right, there is no lacking in your numerator. So what are we going to do with 5 here? We will take that out. So if we are going to take 5 outside of your inverse Laplace transform sign, it will become e raised to minus 5t. By the way, now if you can still recall that e raised to at is equivalent to 1 over s plus 1. By the way, never mind this one. Okay, this is wrong. So I will erase this part first. Okay, pen. So never mind. Oh, I'm sorry. Never mind this function. So this is wrong. Okay, x. Alright, x. Now, since 5 is taken out, now it became e raised to negative 5t. All you have to do next is to take the inverse Laplace transform of your 1 over s squared. So we need to take the inverse Laplace transform. This, what is that? What's the inverse Laplace transform that? Right, that is equivalent to t. So that will become 25 multiplied by e raised to minus 5t multiplied by t. That's the inverse Laplace transform of this function. Okay, let's proceed with our next. Oh, it's your turn. So try to solve this problem here. I will give you 10 minutes now to solve the inverse Laplace transform of the problem shown here. So 5 minutes, take out your paper, pencil, and your calculator. Solve the problem for 10 minutes only. So after 10 minutes, I will show you the answer. Okay, pause the video. I'll wait for 10 minutes. Alright, 10 minutes is over. Are you ready for the final answer? Your final answer would be 4t cubed, that is the inverse Laplace transform of 24 over s cubed, plus 9 e raised to minus t times t squared. That's the inverse Laplace transform. This is actually the inverse Laplace transform of 18 all over s plus 1 cubed. Minus 2 e raised to 3t multiplied by t to the fourth is the inverse Laplace of this function here. Try to solve it again, and then um, try to check if your answer would be the same as mine. Okay. Now for your next problem. Okay, this is your next problem. We have here the inverse Laplace transform of 25s all over s squared minus 4s plus 8. So for 10 minutes. Okay, for 10 minutes you are going to solve this problem. 10 minutes. Okay. Don't forget to pause your video. 10 minutes. Alright, 10 minutes is over. So the final answer would be 25 e raised to 2t multiplied by cosine of 2t. Did you get it right? Okay.